Hey guys, this is Carrie, and in this video we're going to take a closer look at the AP exam. And in particular, I'm going to do an example of the create task, which is what we need to do in order to earn 30% of our AP test credit. So the AP test is broken into two sections. The create task, which we've been practicing a lot for, involves creating a piece of code of your own design. And this is worth 30% of the test. After we complete this, we're going to start to study for the written test, which is worth 70% of the AP exam grade. So I wanted to complete an example create task. So the overall goal of the create task is that you create a piece of code that has a couple of features described by the directions here. So we're going to look more closely at the directions, but let me give you a little bit of motivation for the program that I'm going to be creating. So, from the very beginning of time, people have loved to send secret messages to each other that have been encoded so other people can't read them. So I wrote a secret message here, and if you want, now is a good time to pause the video and see if you can decode my secret message. It's encrypted using an algorithm, using a procedure that you can figure out. It's not too complicated, but it is a little bit hard to see. So see if you can figure out what this secret message says. And when you're ready, you can unpause it, and I'll explain. All right, so I'm going to be creating a brand new applet, and before I start coding, I'm going to explain kind of to myself and to you how we actually decode this thing here. So let me create a new HTML, CSS, and JavaScript applet. I'm going to call it encoder decoder. And this is going to be actually my example create task project. So to give away kind of the answer to this riddle before we jump into coding, I'm going to go to my JavaScript file and I'm just going to write kind of a comment here. So I'm going to copy this and I'm going to say, a comment is the thing that we get when we do //. So an example input could be this. And then what I want my program to be able to do is I want my program to be able to decode this and show us, the user, what the actual sentence says. And the way that the decoding works here is basically, look at the, I'm just going to kind of and this is actually a really useful exercise to think about when you're thinking about your program, is to sort of write in plain English the steps to do whatever you want. But my steps are going to be, to kind of give away the answer here, look at the sentence letter by letter, or actually symbol by symbol. If the sentence, or if the letter, if the symbol is a letter, then what we're going to do is we are actually going to go backwards one letter. So for me, what that would mean would be, for example, Z would go backwards to Y. P would go backwards to O. V would go backwards to A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, T, U. So that first word here, Z, P, V, really goes backwards one letter each to form U. And if you do it to the whole sentence, going through it letter by letter, and actually, if it's not a letter, so for example, I have a space here and an exclamation point. If the symbol is not a letter, we're just going to keep it as is. And so if you do this process to every letter here, we get Y, O, U, non-letter, so we keep it, space. Backwards one each for these. So I becomes H, B becomes A, W becomes V, F becomes E, U have. And if you haven't decoded it to this point, pause here and see if you can do the last two words. And I'm going to give away the answer. You have been HACKED. So the secret message is you have been hacked. And I would like my program to be able to output this to the user by translating this. All right, so how do we get started actually coding this? Well, let me just make sure that my project will involve all of the requirements before I start programming anything. So I'm going to give you guys each a copy, or you should already have a copy of this probably in class, but at this point at 6:21 a.m., I will be giving you guys each a copy of this. This is the submission requirements for your create performance task. So there are 3 parts. You'll be writing some code. You'll be creating a video of you running that code. Not a video of you coding, but a video of you running the code. You'll also be writing some written responses about your coding process. So in this video, we're only going to look at the writing of the program code part of this. So eventually I'm going to turn this all into a PDF file that contains all of my program code, including comments, the green stuff. In general, the thing, and you can read this in more detail, I've kind of already read it this morning, so I'm going to just highlight some of the key points. The requirements, and I'm going to put these in comments as well, just to remind myself of these, is 1, that it has an input from the user. And it could be actually input from a variety of things. We haven't really worked with input from a file, a device, or a data stream, but we've done a lot with input from the user. So that could be clicking the mouse, which we're going to have here because we're going to have buttons. It could also be typing in sentences and words, which we're going to have here because we want the program to be able to decode any input. So the user will put their input. So I'm going to do user input as the first requirement. The second requirement is use of at least one list. So the list requirement, in JavaScript, we call list arrays, as it outlines in the side column here, but I frequently call them list in the video. So we've worked with a lot of lists. They're the stuff that goes in between the square parentheses. So one of the ways I'm going to use a list in this program is I'm going to convert this string to a list of letters and symbols so that we can go through and we can decode it. And so I'm definitely going to have a list that's useful in my program because I'm going to go through this as a list, or I'm going to convert this string to a list and then go through the list item by item. Next up, we're going to need to have at least one procedure that contributes to the program's intended purpose. So whenever we say the word procedure in JavaScript, we haven't worked too much with procedures that have used names, but in our last project we did a lot of this. The game project, we would be writing these functions, things like draw bad guy. And so we want to make sure that we have a procedure in our code, which will be a function like draw bad guy. In this case, I'm not exactly sure what my function is going to be, but I'm definitely going to have a lot of different procedures here, and I'm pretty sure that I can reframe some of it as a function. Next up, we're going to have at least one procedure. Sorry, that's what I just read. An algorithm. So an algorithm is like a recipe. It's a sequence of code that does a certain thing. So in fact, an algorithm is a step-by-step process. And they want our algorithm to include these 3 elements: sequencing, selection, and iteration. So for simplicity, I want to define those here. Sequencing is, since an algorithm is a step-by-step process, sequencing is the order of the steps matters. And so actually, if I think about where is my algorithm going to be in my code, we actually already described the algorithm up here. It was the process that we're going to use, the step-by-step process that allows us to translate ciphered text to deciphered text. And the order of the steps matters a lot, right? We have to look at this symbol by symbol. We have to go backwards for each symbol. And we'll see more specifically here actually how we write this in code, that the order matters even more because we have to break down some of these steps into smaller steps. Selection. So selection is this idea that depending on what we're looking at, we'll have to use if and else if statements to do different things. use if/else statements to do different things. So I'm going to have a couple of places where selection comes up in my code. But one example is if the symbol is a letter, we're going to actually do this going backwards thing. And otherwise, we're going to just include the symbol. So this is an example of selection because it uses if and else statements to do two different things depending on what it's looking at. And the final requirement for our algorithm is the one that we've probably spent the most time on this year, which is called iteration. So iteration is loops. And in my case, so iteration is something that repeats over time or repeats through something. In my case, I'm definitely going to have iteration. I'm probably going to have a for each loop because I'm going to want to do the same thing for each symbol. So in my case, I will be using a for each loop, probably. Okay, I have to have a call to my student developed procedure. So here we're going to write the procedure, and then later we have to use our procedure. Instructions for output. Okay, so we need to have an output. The output is going to be the example text here. In other contexts, the output might be, like if you're designing a game, the output would be maybe what's happening on the canvas for the game. That would be output being displayed to the user. So as you draw the different characters in their new positions and stuff like that. All right, well, I think that this program is going to satisfy the 6 requirements. We've got an in-person, like an in English description of the task here. Let's start coding. So it's been a while. I'm going to pop over to the HTML here, and we've been doing the canvas for a long time. So just a brief reminder of what it's like to code without using the canvas. I'm going to create a div with a class of content. So I do div.content, press tab, and that makes a div with a class of content. I'm going to put my whole program inside of here. So let's see what that means. I'm going to have an h1. And the name of this particular cipher is called the Caesar cipher. It's named after Julius Caesar because he used to use it to send messages to his troops in the field. I'm going to give an h2 here, says a program by Carrie. But I may have to delete this later. I'm not sure if I'm allowed to include my name when I submit my final program, so we'll see. I'm going to include a paragraph here, which will say, write your encrypted text below. Include the shift amount. So I want the user to input here this and say that it's been shifted by 1 letter. We could have imagined that this cipher instead would have been shifted by 2 letters, and then we would have had to go back not just 1 letter, but 2. So write your encrypted text below, include the shift amount also. So then I'm going to create a paragraph here, and I'm going to say encrypted text. I never know how to spell encrypted. Encrypted text, ... input, tab. And now I'd like to create some text input here. I think that looks good. Let me pop this open to see how it's coming along. So if you get the same error here, let's see. I'm not sure why I'm getting this error. I think it's just loading. All right, so write your encrypted text below, include the shift amount also. So I'm going to do that. Let me refresh this. Let's look at this here. Okay, cool, great. So it's loaded up here. A program by Carrie, write your encrypted text below. So we're going to write our encrypted text here. Then on the next line, I'm going to put shift amount. And let's refresh it. I don't know why it's so slow. This one is going to be a number. So I'm going to call this type number. I'm also going to change these so that they have an ID because I'd like to be able to get the values from these different inputs. So I'm going to call this cipher input. And then I'm going to call this one ID shift number input. Okay, cool. Let's refresh that. So now this one is a number where you can do this. I don't really like that. And this one is encrypted text where we can write like that. I think I just need a button. So let's see, write your encrypted text below, include the shift amount also. Press the button to decrypt the text. I guess if we're spelling encrypt with a Y, decrypt should be with a Y too. And then I'm also going to include a place in my div for the output. So I'm going to put a paragraph here, and I'm going to give this paragraph an ID of output. Oh, I have my keyboard set up for something else. There we go. Output. There we go. Cool. ID is output for that paragraph. And so we're going to put the output text here. All right, so now we've got the basic setup for our user interface. It's time for us to style it very briefly. So I'm going to pop over to the style. I'm going to take the .content div, and I'm going to give it a fixed width of 600 pixels. I'm going to give it a background color of yellow. I'm going to center it by doing display block margin auto, just like we do for pictures. I wish that my thing was reloading faster here. I'm going to add some padding to it because I noticed the text is right up against the edge. So padding 10 pixels. Cool. I'm going to take some apply some styles to the H1, which would be like a text align center. I'm going to apply the same style to the H2. So these should be centered now when it finally reloads. Cool. I'm going to take this text input, and I have to go back here and actually figure out the name here, Cipher input. So I'll say hashtag Cipher input. So the one with the ID of Cipher input is this one, and I want the width of that to be a little bit larger. So let me make that 400 pixels. Let's see how that looks. Cool, that's looking a little better. And the shift amount can stay tiny. I forgot to put the button, so let me go back here and put a button. I'm going to put the button before the output, so the button is going to say Decipher. And so when we click the Decipher button, I would like it to actually translate the code. All right, so I want to keep the styling simple, basically, because I don't want to spend too much of the video styling. Of course, you can spend more time styling. The one thing I am going to do is I'm going to apply a font to all of this, because I don't like this font. So I'm going to say select everything on the page with the global selector. And then for font family here, I'm going to do sans serif. Or actually, monospace is pretty fun for this one. Let me do monospace. Cool. Okay, it looks kind of like a code thing now, so I sort of like this. Okay, great. Everything is monospace. Perfect. Should we add a background to the page? Sure. So body, background, and remember that you can always use the color picker here to find a more exact color that you like. So I'm going to choose just like a super dark blue for the background color here. And I'm just going to copy this hex code, semicolon. So it's displaying the colors a little differently now, which is really nice, actually. And now if I refresh this, it should have a background for the body element. Great. All right, so none of this actually gets me any credit, I think, for my AP exam. But it's important, because now I have a user interface where I can actually code those things that are required according to the directions of my AP task. So I'm going to go to the JavaScript here, and I'm going to actually try to implement all of this stuff that we were just describing. So let's see. Let me start by selecting the elements on the page that we're going to interact with. So let Cipher text input equal, it's Cipher input and shift number input. Okay, so let Cipher input equal the thing with the ID, document.querySelector, the thing with the ID of Cipher input. Okay. Let me move this further over so it's easier to see. Semicolon. All right, I also want to get the other thing, the other input down here, the shift number input. So I did the multi-selector, and now I'm doing shift number input is the thing with ID shift number input. Cool. We also want to get the button. The button doesn't have an ID, so let me just call it let button equal, go to the document.querySelector, and select the thing with not ID of button, so I'm going to leave out the hashtag. It's just going to be button as the type. All right, so I know we're interacting with these three things. Where am I going to put the output text? Well, I have to select the element where I'm going to put the output text, which is the paragraph with an ID of output. So let output paragraph equal document.querySelector, the thing with the ID of output. Okay, cool. So I think we've got all four things we're going to interact with. So next up, we want to build up this program. So I'm going to write an event listener for the button. So button.add event listener. It's going to be a click event. And then the function that we're going to run is going to be my big algorithm here from part 4. So here I'm going to outline my step-by-step process of what exactly I need to do in order to decrypt this text. All right, so let's see. First thing we need to do is we need to actually get the text. So when we click the button, let's let Cipher text equal. Go to the Cipher input field. And we've worked with inputs before. To get data from an input element, we do input element.value. So I'm going to go to the Cipher input, which is this field here, and I'm going to get the value of that. Now I'm just going to do a console.log Cipher text in order to see if this is working. So let me refresh my page, let me type in some text there and decipher. And yes, it is reading the text from there. That looks great. I'll also need to get the shift amount. So I'm going to say let shift equal. Go to the shift number input and get the value from that. Let's do a console.log of this as well. So this is really useful to, talking and typing at the same time. This is really useful to do because the console logs are really useful to do because they allow us to kind of check our program along the way. So let's just see if that works. Okay, and if we change this number here and press decipher, and if we change our message there, yes, everything works. So Replit is having some problems here. Okay, here we go. So let's see, what's the next thing to do? Okay, we've got our shift cipher text, we've got our shift value. I would like to actually also have access to an alphabet. So I'm going to create a variable called alphabet. And I'm sure I can find this online, but I'm just going to write the alphabet as a string here. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay, so there's the alphabet. So now our program should have access to this whenever we type the word alphabet. So you can see here that even in the console, if we type alphabet, it will reference this string. But instead of actually seeing this as a string, I would like it to be able to see these letters as separate letters within a list. So to convert this to a list in JavaScript, I think I can just do this. I might be thinking of Python though. Let's just see if that works. I think this isn't going to work. Okay, so let's Google this. Convert string to list JavaScript. There's usually an easy way to do this. Okay, let's see if we can use dot split. So I'm going to take away this, and I'm going to say take this string, and then apply the dot split method to it. Let's see if this works. And now if we type in alphabet, it did not split it. So what we need to do is we need to tell it which character to split on. So I'm going to say to split on the empty character, which should hopefully split this every character along here. All right, so the replit is not running. Here we go, alphabet, and now we've got our alphabet split so all the letters are separate. So what we did here is we took a string and we split it up so that the gap in between the different strings was just any place where we have a character, or splitting on the empty character means split, 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 split after each thing. Okay, so now the alphabet is set up there. Awesome. I think we also want to do the same thing with our ciphertext. So when we type in that and then 4, I'd also like to take the ciphertext and split this up to a list. So ciphertext is equal to, go to the cipher input and get the value. Let cipher list equal, take ciphertext, and we want to split it up the exact same way that we split up this alphabet. So ciphertext dot split, and we're going to split it on the empty character so that it splits all of these into letters in a list. So let's change this since now we're using cipher list. Oops, I didn't think it refreshed. Okay, great. So it takes my ciphertext and splits it up letter by letter. Perfect. Okay, cool. So now what we need to do is we need to actually start building up our answer. So I'm going to say let answer equal. Let's see. The answer is going to start off with nothing in it. It's going to start off as the empty string. And then letter by letter or character by character, we're going to go through this and translate them using the shift amounts in order to get the right answer. So let's see. Because cipher list refers to this list that has all of the different letters in it, I'm going to say cipher list dot for each, which sets up a loop that's going to go through each one of these. So now I'm working in some iteration, and it's going to go through it letter by letter. And actually a better word for this would be symbol, but I think symbol is a protected word in JavaScript. So I'm just going to say SYM. So it's going to go through it symbol by symbol, this thing right here. Sim, 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 and then stop. Okay, let's see. And what I want to do is I want to have a function here. Oh, sorry, arrow functions, we don't write function. This is a mistake I keep making. So take sim, and then run this code block. And the code block that we're going to run is we're going to say if the symbol is inside of the alphabet, then we want to do something with it. Otherwise, we want to just, so if the symbol is in the alphabet, I'm going to put a momentary in English here. If the symbol is in the alphabet, and that's not code, I'm going to come back to that. Then what we want to do is we want to translate it, or use the procedure to decrypt it. Otherwise, what we're going to do is we're going to say, take the answer variable that we've created here and make the new answer variable equal to, make the new answer equal to the old answer plus the symbol that we're currently on. That way, if it's something like an exclamation point, we would just be able to add to our answer the current symbol. Or if it's a space, like our example, you have been hacked, it will just take the space and add it to our answer without trying to do this go back one thing. All right, so let's see. If the symbol is in the alphabet, okay. So, let's see. How do we figure out if something is in the alphabet? Well, I think this is a good opportunity for us to actually create our procedure here. So I'm going to create an in alphabet procedure. So function in alphabet. And the in alphabet procedure is going to take a letter as the input. And what it's going to do is it's going to tell me if the letter is in this alphabet variable. So the way that we can do that is there's something called index of. So index of JavaScript. So here we have an array, a list, similar to what we have with our alphabet. And what we can say is here, let's look at the examples here. So bison, if you go to beast, index of bison, it's 0, 1. Perfect. I have no idea what this means with the extra number, so I'm going to skip it. But what's important for us is what happens if we check for an animal that's not included. So if we go beast.index of giraffe, giraffe is not included. That gives us a -1. So here, if I want to check to see if something is a letter, this will take a symbol, not a letter. If I want to check if this symbol is in the alphabet, then what we're going to do is we're going to say, go to the alphabet list and find the index of the symbol. And I'm going to call this alphabet position. So I'll say let alphabet position equal, go to the alphabet and find the index of the symbol. So for A, it will return 0 because A is the 0th symbol in this list. For Z, it will return 0, 1, 2, 3, 4, 5. It will return 25 because Z is the 20th symbol. But if we check something like the exclamation point, it should return -1 because the exclamation point will not be included in this list. So here we go. If the alphabet position, and this has to go in parentheses here, if the alphabet position is -1, then I would like this to return false, because -1 means that the symbol is not in the alphabet. False is not spelled like that. If it's anything else, then I would like to return true. And so what return does is it says, okay, run this procedure, and output false, return is like output false, or output true, depending on whether it was in the alphabet or not. Depending on whether we found that, because -1, right, is the symbol that it's not included. So let's just check this. Unexpected identifier in line 43. Oh, here we go. Line 43. I'm going to momentarily comment these out by highlighting them and pressing Command/. Okay, so here we go. I wanted to check my in alphabet procedure here to see if it works. So I'm going to try it with A. So A is true because A is in the alphabet. I'm going to check it with exclamation point. That shows false. I'm going to check it with space. That shows false. P is in the alphabet. T is in the alphabet. Y is in the alphabet. And you can see that's just returning a true or false value depending on whether something is in the alphabet or not. So super cool. Our in alphabet function is working. So where that plays a role now is I'm going to come back here. I'm going to press Command/. So I'm going to actually use this procedure here. So this is the using our procedure part. So here for part 3, we wrote a function. Now when we use it, what we're going to say is if the current symbol is in the alphabet, so if in alphabet symbol. So if this is true, if it's in the alphabet, when we run this, it returns true, then what it's going to do is it's going to decrypt it. Otherwise, it will just take the symbol and add it to our answer that's being built up. So let's see. What does it actually mean to run the procedure here? What it means is, once we know it's a letter, we have to go back a couple of spaces based on the shift amount. So let's get the index of the letter, or the position of the letter in the alphabet. Let position of letter equal. And actually, we can use this index of function again. Here in our alphabet, the index is the position in the alphabet, so B will be position 1. And using the back 1 cipher, we would go back 1 position, so B would translate to the 0th position thing, which is A. So to get the position of the letter, I'm going to say, go to the alphabet, which is that list of all the letters, and find the index of the symbol. And now that we know it's a letter, we know that we're going to get a value from 0 to 25. Next up, let's see. We want to get the new position. So let new position equal, take the old position and subtract off the shift value here. So if our shift is 1, if the old position is 2, like C, then we want it to become B, which would be new position is the old position 2 minus 1, because the shift is only 1. Now this is going to work for every letter. 25 will shift to 24, 24 will shift to 23, and so on. Except A is at position 0, and position 0 will shift to -1. And there isn't a -1th element in our list. So here we can use another if statement. What we really want A to do is when A shifts to -1, we want A to really become Z, which is position 25. So mathematically what that means is if the new position is less than 0, if it's a negative number, then the new position should actually be equal to the old new position, which was the negative number, plus 26. Because that will reset it back to the end here. So if A is shifted back by 1, it becomes -1 plus 26 is position 25. If we were doing a shift of 2, then A would shift back 2 to -2 plus 26 would give us 24, which would be Y. And that would actually represent a shift of 2 because A, Z, Y. So I think now we are all set up with our new position. And finally, what we want to do is we want to get the new letter. The new letter is going to be equal to go to the alphabet list, which we're calling alphabet, and get the thing that's at position new position. So what that would mean is go into this alphabet list, and if A shifts back by 1, or sorry, let's not use A because that's one of the weird ones. So F would be 0, 1, 2, 3, 4, 5. So the old position is 5. The new position would be 5 minus 1. 0, 1, 2, 3, 4. So then the new letter would be the thing at position 4. So go to the alphabet, position 4, the new letter is E. And then finally what we want to do is we want to take our answer, and we want to make it equal to our old answer plus the new letter. So I think this is actually going to give us a completed answer here. And then finally what we want to do is we want to go to the output spot that we created, and we're going to make the inner HTML of that equal to our answer that we just created, symbol by symbol. So let's see if our code works here. We may have some errors. Let's see what happens. I'm going to delete this now. So let me put in my example text here. And I'm going to say shift amount 1. Old position is not defined. New position is equal to, here I called it position of letter. I'm going to call this the old position of the letter. Because it's the old position, so like, if we go to the alphabet and we find the index of F, the old position, 0, 1, 2, 3, 4, 5, the old position will be 5. Then the new position will be 5 minus the shift. So let's see if this works again. Let me paste that. Shift amount by 1. Output is not defined. Let's see. I called it output paragraph. So we want to say output paragraph dot inner HTML. All right, checking it again. Nope, didn't refresh. Cannot set properties of null, this inner HTML. So output paragraph was document.query selector, the thing with ID of output. Let's see why that's giving us an error. Oh, I misspelled output. All right. Finally, I think this will be the one that works. You have been hacked. So it deciphered it properly. Now, if we do a shift amount of 2, I don't think it's going to make sense, but Z should become shifted by 2, Y, X. Let's check out if position this works. So Z becomes X, C shifted back 2 becomes C, B, A. Yes, that works. Here's B. B is interesting. So B shifted back 2 would be B, A, and then back to the end, Z. Yes, it works. So it looks like our cipher is shifting all of this stuff. And if we took a different message and it was encoded, I only have this example of an encoded message, we could actually decode it using various shift amounts until it started to make sense. So there's a lot of places that I could continue to work on this code, but I just want to make sure before I submit it that I've satisfied the requirements of the project. So does it use user input? Yes. Does it use a list? It uses a couple of lists. We have our alphabet list when we split this up into different lists, like different letters. We also split up our input text into a cipher list by taking this and looking at it letter by letter. Does it use a procedure? Yeah, I defined a function here to check if something was in the alphabet. And then later we used our procedure here to check if something was in the alphabet using our procedure here. We would do different things. Do we have an algorithm, a step-by-step process here? Absolutely. We have a sequence of steps that matters. We have to do these in order. We have to get the text. We have to turn that into a list before we can do anything else. And then for our list here, the order of the steps matters as well. Do we have selection? Yes. We have an if or else statement, which means if something is a letter, we do one thing, we select 4 letters, and if it's anything else, we do a much simpler procedure, which is we don't shift these. Exclamation point stays exclamation point. Space stays space, because they're not letters. Do we have iteration? Absolutely. Iteration is a loop. We use a for each loop right here. And finally, do we have an answer that's being outputted? Absolutely. We have output, and it's being displayed on our page right here. So this would be a complete create task that I think this code would receive full credit. And hopefully it's a cool example for you to use when you're thinking about your create task. You could also obviously add things to a game that we've already made, use the canvas, but I just wanted to show you that some of the stuff we were doing earlier in the semester also works really well for this type of assignment.